Amen. Amen. തുടങ്ങാം.
തുടങ്ങിയേക്കാം ഡോക്ടർ, തുടങ്ങിയേക്കാം.
പക്ഷെ എല്ലാരോടും മൈക്ക് ഒന്ന് മ്യൂട്ട് ചെയ്തേക്കാൻ പറഞ്ഞു. സ്പീക്ക് ചെയ്യാത്തവര്. I think the co-host can do. വിഷി നിങ്ങൾക്ക് ചെയ്യാൻ പറ്റൂലേ മ്യൂട്ട് ചെയ്യാൻ?
കുഴപ്പമില്ല ഡോക്ടർ, ഞാനിത് പറയാൻ കൂടി ചെയ്തോളാം. ഞാനിന്ന് സ്റ്റാർട്ട് ചെയ്തോട്ടോ ഡോക്ടറെ?
ഓക്കെ, തുടങ്ങാം.
Good evening, dear attendees. We are about to begin with our webinar. Before we start, I request you all to mute your mic throughout the section. Any doubt or question can be asked through the chat box or comment session. Also, for your information, the program will be streaming live on the YouTube channel. The link can be found in the chat box. Let's start with the section with a silent prayer for 5 seconds. So once again, a very warm welcome to one and all. I, Dr. Ashish, on behalf of the IDEA Center Kerala Kottayam, would like to extend a very warm welcome to all gathered here for the first webinar of our branch. So without much delay, let us move on with our today's program. I invite President IDEA Center Kerala Kottayam, Dr. Manoj Thomas, to deliver the welcome speech and presidential address.
Good evening all. I am Dr. Manoj, President IDEA CKK. Today we are starting our first CD program as a webinar, which is based on light care composites. And today we got one of the most eminent, young and dynamic and very knowledgeable speaker, Vijit Narayana, with us for his presentation. You all know he is very young and very updated in dentistry, because dentistry is growing leaps and bounds and it is progressing very fast in these days, and we have to keep in pace to be in practice. So today's CDs will help you in updating yourself in the recent developments of coming in conservative and conservative dentistry, actually in composites. So we got one of the apt speakers for this program, Vijit Krishna, who completed his MDS from Trivandrum Dental College. And today I welcome him to our program. And today we are having the young, vibrant and most friendly CD chairman of Indian Dental Association Center, Kerala State, Nithin Krishna, also with us to inaugurate our CD program. I welcome Nithin Krishna to this meeting. And as you all know, the man behind this program is our own very enthusiastic, young, active and hardworking CD chairman, Ashish. I welcome him also to the meeting. And you all know the pride of the charming, charismatic, able Vice President of Indian Dental Association, Kerala State, and the pride of Central Kerala, Sherry M. Joseph, is also with us. I welcome him also to this program, and he is one of the most active members of IDEA CKK, Sherry M. Joseph. And I welcome our senior members, most of them are here, and young members, as well as our executive members and all members to this program, and hope that you all will benefit from this program. And Idea CKK will come out with more of this kind of programs for the benefit of its members. And we wish, and I wish, a good learning day for all of us. Thank you. Or to Ashish.
Thank you, Dr. Manoj. Now, we are honored with the presence of IDA Kerala State CD Chairman Dr. Nishant Krishna joining us from Trivandrum. Dr. Nishant Krishna graduated from Sri Mugambika Institute of Dental Science. He has been an active member of Indian Dental Association since 2007 and has served as CD convener, vice president, and currently the honorary treasurer of IDA Trivandrum branch. He is an executive member of IDA Kerala State from 2015 and recipient of Excellence Award for the year 2020. Now I invite Dr. Nishant Krishna to inaugurate the CD activities of IDA Central Kerala Kottayam for the year 2022 and also for addressing the gathering.
Thank you, Doctor. Am I audible?
Yes.
You're audible, Doctor.
First of all, good evening to all of you. President Dr. Manoj Thomas, Secretary Dr. Rishi Ram, State Vice President Dr. Sharian Joseph, CD Convener Dr. Ashish Dev. This occasion, I would like to Office Bearers for inviting me to inaugurate such a program. Am I audible? Hello?
Yes, Doctor. The slight disturbance is there, but still you're audible.
I hope the session will be a knowledgeable one. On this occasion, I personally would like to greet the past office bearers of IDS and Secretary Dr. Nitin Joseph and President Dr. Anigesh for securing IDA Kerala State Branch Awards. Not prolonging my speech very much. Let's move on to the official part for which I'm called for. I hereby declare the webinar and the CD activities of IDS inaugurated. Thank you.
Thank you, Dr. Nishant Krishna. Now, in a few minutes from now, we will be listening to Dr. Vijit Narayana, an endodontist by profession and a gifted wildlife photographer by passion. Dr. Vijit did his graduation and post-graduation from GDC Trivandrum. He has undergone clinical training on implantology. He is an active member of Conservative and Endodontic Society of Kerala and Indian Association of Conservative Dentistry and Endodontics. He is a speaker for Dentsply Sirona. He is practicing in Kochi, focusing on microscope-enhanced endodontics and aesthetic dentistry, along with wife Dr. Kavita Kumar, who is a pediodontist. He has lectured and conducted training programs on endodontics and aesthetic dentistry on various platforms in IDA and at his own facility at Kochi. He bagged Kerala Dental Council Award for conducting second highest number of CDs as CD convener in the year 2016-17 and IDA Award as CD convener in 2019-20. He will be speaking of the topic Light Cure, the magic wand of composite. I invite Dr. Vijit Narayana to enlighten us with his knowledge.
Yes, thank you, Dr. Ashish, for your kind words. Thank you, IDA CKK, for inviting me here, and special thanks to Robin sir for choosing me as the inaugural speaker of your CD activities. Before I start, I would like to recognize the presence of many of my teachers here, which makes me more nervous to speak in front of such an august audience. And I also have my OPG and your own Dr. Liba Varghese also attending the meeting. Anyway, we'll directly start off with the presentation or with the discussion as such, which I would like to call as vitamin LC, because it gives your restorations longer life and makes it much more stronger. Okay, as already mentioned, I completed my BDS and MDS from Government Dental College, Thiruvananthapuram, and this is where I practice Innocent Smiles Dental Clinic, which is at Cochin, a place called Kakanad, and I've been practicing here for the last 10 years. And this is the way most of our composite sessions end, and then you light cure. We discuss in detail about newer techniques, newer materials, and all whatnot, or newer science about composite restorations. And most of the presentations end in this fashion, these simple 5 words, and then you light cure. It's like telling after a marriage that and they have lived happily ever after, because we know the struggle actually starts after that slide. It's not the end, but the beginning of the further struggles. So we would start our presentation with this last slide, which most of the presentations end. Okay. Now there are lots of questions when we talk about light curing. Which curing light to buy? Are polywave lights or the multi-wave lights worth the cost? How long to cure? What is the increment size of composite that allows for a good cure? How many curing lights do we need? There are techniques which describe 2 or 3 curing lights. I don't know how they are inserting so many curing lights inside the mouth. But anyway, there are techniques which suggest using 3 curing lights at the same time. And the questions goes on and on and on. So the big question remains here, which curing light to buy? And if you are here to know the answer to this, I'm very sorry, because I cannot give you a single answer, because there are so many to choose from. You can think about curing lights right from 1,500 rupees to around 2.5 lakhs. So if I tell you that the 2.5 lakhs one is the best, you may probably shut down this presentation right now and go away. So I'm not here to give you an explanation or to give you a choice. Rather, I will give you what a principal discussion about what to choose. ഒരു താത്വികമായ അവലോകനം തന്നെയാണ് നമ്മൾ ഇവിടെ നടത്താൻ പോകുന്നത്. അതാണ് എൻ്റെ ഉദ്ദേശം. So we'll start with that very historical dialogue. What to expect from this presentation? How to maximize your returns from the existing machine. It's not possible to invest in a new machine as soon as you hear a presentation. So we are not talking about buying any new things, but how to maximize your returns, how to benefit maximum from your existing machine, and the tips to improve curing. How can you maximize, how can you improve the curing with your existing machine? How to maintain your existing machine so that you get the maximum from it, or you get the maximum life or service from it, and some of the safety precautions. Yes, we need to take some safety precautions, which probably we were not really aware of till now. So I'll try to keep the presentation as simple and clinically relevant as possible. Maybe the doubts we can take later, and I'll try to keep it as short also. Okay, so this I will start with this very simple question. Do we need to switch off the chair light during a light curing? Many of the you, I mean, I'm not asking for an answer here, but many of us, we still continue to switch off the light during light curing. Maybe this wisdom was transferred to us from our predecessors probably, and we have never questioned, why should I switch off the light? What is the advantage if I switch off the light? But you just go through if you just go through the literature, you can see there are lots of studies similar to one that I've shown here, which shows that the average micro hardness of the cured composite was higher if LED light, I mean, if the chair light was on during light curing, which means that you need not switch off your curing light. If you switch off the curing light, what is the disadvantage that we get? We are actually on a, I mean, we are actually losing on the vision. So we need the chair light to visualize what is inside the patient's mouth. So don't switch off the chair light when you are curing. Maybe you can bring the curing, bring down the intensity of the chair light. If your chair has 2 or 3 intensities, you can bring down the intensity of the chair light, because that is when you are working with the composite, because intense chair lights also can reduce the working time of the composite. You may end up having a prematurely cured composite even when while you are packing the composite inside the preparation. So that is one idea, that you can reduce the intensity of the light when you are working with the restoration. Okay, so we'll start off with the basics of composite curing, just a very little theory of what to expect. So composites, they set by 2 techniques or 2 methods. One is self or chemical polymerization, and the other one is light or photo-initiated polymerization. Since our discussion point of discussion today is light initiated polymerization, we'll just see what are the components of a light cure composite. I mean, what are the components that lead to light curing. So we have 2 components in a standard light cure composite. One is a photosensitizer and the other one is a amine initiator. In some of the others, they call it photo initiator and co-initiator. Okay, the photo initiator that we most commonly see, or you can say 99% of all the photo initiators that are used in dentistry is camphoroquinone. Now, what happens with while we do the light curing is that when the light falls on the photosensitizer, it gets sensitized. That's why it's called a photosensitizer. It gets sensitized when the light falls on the photosensitizer. And the sensitized photosensitizer, or the camphoroquinone, reacts with the co-initiator, which is an amine. Okay, now this amine, this reaction, what this does is this activates the amine initiator, which produces free radical. And now this free radical is what starts with the, and this free radical is what starts with the addition polymerization. So this is the basic chemical reaction that occurs while you heat a light of 470 nanometer. That's an approximate value. The range is a bit bigger, but 470 is the approximate wavelength of the light that is emitted by our curing light. So this is the basis of our photo initiated polymerization, or the light polymerization, or the light curing. Now, what are these photosensitizers? The most commonly used photosensitizer is camphoroquinone. Yeah, the most commonly used photosensitizer is the camphoroquinone, which absorbs the light in the range of 468 to 470 nanometers, which is very bright yellow in color. It looks something like this. It looks like a turmeric powder, nothing else. So there is a big disadvantage of this bright yellow color, that this color is imparted into the composite. So if it's a dark shade composite, this gets gelled with the composite and then it's not a problem. But if it's a light shade composite, like the recent popular bleach shades, for example, you cannot use camphoroquinone beyond a particular extent, because this bright color, yellow color, will be imparted into it. So to overcome some of the disadvantages of this camphoroquinone, recent advances include something called as TPO. Now, many of, it's not very common, it's not very popular also. A majority of the composites that we get today, they do not have this, but we should all know, because of the increasing popularity of the bleach shades, which is not very popular in our country yet, but bleach shades are very popular elsewhere. So when more of bleach shades are coming, you see the increased use of these kinds of photosensitizers like Lucerne TPO or ivoserine. Basically, vinyl propadione is not so popular, but ivoserine, that is a benzoyl germanium derivative, that's quite popular, especially with a few brands of Ivoclar composites. You see this ivoserine, patented by Ivoclar, basically. So these are the photosensitizers that you see in the bleach or translucent shades. Now, just to see what is the what wavelength of light does sorry, what wavelength of light each of these photo initiators absorb. You can see this is the camphoroquinone. The peak is at the range of around 470 nanometers, whereas TPO, the range, the peak is somewhere around 400 to 410 nanometers, which is we can say which is that nanometer, that wavelength is related to violet light. This 470 is related to blue light. And ivosarine also somewhere around this 430 to 450 is the peak of light absorption. So these are the different photo initiators. We'll discuss about the clinical implications later, but just to know that we have different kinds of photo initiators coming up, and these are not used exclusively. Most of the time, these are very small in amount. Camphoroquinone still remains the most popular and used majorly everywhere. Okay, a few term, just a couple of terminologies. One is about degree of conversion. What is degree of conversion? Is the percentage of monomer that converts into polymer. We know that composite as such is a monomer, and that is converted into a polymer when you cure it with your curing light, or whether it goes, if it undergoes chemical curing, it becomes a polymer. Okay, so degree of conversion is nothing but what percentage of monomer is getting converted into polymer. Practically, this is around 55 to 65%. That's all. You do not get 100% polymerization with light cure alone. So this is somewhere around 55 to 65. This is what you should expect. Now, this means that around 35 to 45% of the other, the 35 to 45% is unreacted monomer or unconverted monomer. It's purely monomer. So with poor lighting, what happens? This even this goes even below 55 to 65%, which means that your composite may look hard, but it's not properly cured if your light curing is not proper, and that is where the significance of proper light curing comes. What happens when there is more amount of monomer? The serviceability of the light, of the restoration comes down drastically, which we will explain in a few slides. Okay, the another terminology that I would like to share is the depth of cure. Depth of cure is a property of the curing light. It refers to the depth to which the curing light can polymerize, and this is directly related to the depth of penetration of the light. See, the light can polymerize or cure the composite up to a distance to which it can penetrate. If it does not penetrate beyond a particular distance, it will not polymerize. So ultimately what happens is, to point where which the light reaches, the composite gets cured. Beyond that, the composite doesn't get cured. And depth of penetration is directly related to the wavelength of the light, which means that when the wavelength increases, the depth of penetration also increases. When the wavelength decreases, the depth of penetration also decreases. With, for example, in case of ultraviolet rays, which has a wavelength lesser than that of blue light or the visible light. So ultraviolet rays has a depth of penetration of maximum of 1 millimeter into composite, whereas curing your visible light has a depth of penetration of approximately 2 to 2.5 millimeters. So for blue light, the depth of cure in composite is around 2 millimeters. So why is curing critical? It is a decisive factor which decides whether your restoration is a failed restoration or a successful restoration. Irrespective of the kind of quality of technique that you have employed or the quality of the restorative material that you have used, irrespective of whether you have done it under the best isolation possible, if the curing is not proper, your restoration is bound to fail. So if you ask me which is the most important aspect of composite restoration, I think it is the curing, because it is the most overlooked aspect of your restorative dentistry, composite restorations. So what are the consequences of inadequate lighting? You can think about all kinds of failures if your composite is not cured properly. The bond strength reduces, which means that your composite can dislodge any debond anytime after you do the restoration. There will be lots of micro leakage because there is no proper bond between the tooth and the composite. So the marginal micro leakage is always there. Post-operative sensitivity, again because of improper curing. Pulpal toxicity, as described earlier, as the amount of monomer increases, the toxicity of the material also increases. We know that BisGMA as a monomer is very toxic, but as a polymer, it is one of the most biocompatible materials. So the more the unreacted BisGMA, higher will be the pulpal toxicity. And that is one of the very big reasons why majority of earlier composite restorations used to come with a non-vital tooth after 6 months. That was because of the pulpal toxicity of improperly cured BisGMA. Again, recurrent caries as a result of micro leakage. Lack of color stability, basically because BisGMA is not properly monomerized, and as such BisGMA gets converted, it gets discolored very fast. So you can think about all kinds of failures if your light curing is not proper. Poor mechanical properties, your restoration will wear off very fast or can fracture under occlusive pressure. So how to achieve optimum curing? Having said all these things, we need to have an understanding of how to achieve optimum curing. Unfortunately, there is no single criteria to diagnose whether your restoration is cured or not. You cannot look at the restoration and tell that it is cured, or you cannot touch the restoration if it looks hard, which means that it's cured. Hard to touch is not at all a criteria, because your tactile sensation has no objective measurements. It just gives you a very subjective measurement, which is totally unreliable if you go by it. So hard to touch cannot be considered as a criteria for optimum curing. Especially, what can you touch? Only the surface, and surface may be hard or may be cured, but the bulk of the restoration may still be uncured. Okay, here comes the importance of a magic wand. Do we have a magic wand in dentistry? As such, we do not have a magic wand, but we have something called as a light curing unit, which is not at all a magic wand. But if we manage the variables properly, we can simply go ahead and make use of it as a magic wand. So we'll see what are the basic variables of a light cure composite, light cure unit. Before that, let's just for the sake of thank you. Right. So just for the sake of understanding, those who don't know that the curing lights that we get nowadays are LED lights. I don't think we still have the halogen lights because of the high heat and the weight that it creates, that it has. So most of the lights that we use now are LED lights, and they emit visible light. Many of us still have a misunderstanding when we are dealing with some kind of ultraviolet or something of that range. We are not at all dealing with ultraviolet rays. We are dealing with visible light, and that too blue light at the range of around 470 nanometers. Now that is the case if your light curing unit is a standard LED light unit. You have newer generations, which we'll discuss a bit later. So this is the basic of curing light. Now about the variables of light curing, we have basically 4 variables, 4 large sections of variables, which was described by Dr. Price in 2010. He has done a lot of research. Until 2019, we have lots of articles by Price, which describes the various variables of your light curing system. So we'll just, these variables were called as core variables. Core variables, we start with the first one, that is curing light characteristics, the characteristics of your light cure unit. Then the operator technique, which is very important, and probably the most important aspect that we will discuss today is the operator technique. Then for the restoration characteristic, about the position and depth of the restoration or the accessibility of the restoration, and on the energy requirements of the composite, which we cannot do anything. It has to be done by the manufacturer. So our tech, all these things has to be adjusted according to the energy requirement of the composite. We will discuss these four variables in detail. You already know about curing lights. We have curing lights from even cheaper than 2.5 thousand. It's 1,500 model. You have curing lights available. So what are the characteristics of curing light? One is irradiance, which we'll discuss in detail. Diameter of the light guide tip, spectral irradiance, uniformity of irradiance across the diameter. Don't worry, we will be discussing all this in brief in the following slides, and the quality of beam. So irradiance, it's kind of a misnomer to tell intensity, but it's okay. For ease of understanding, we will keep irradiance as intensity, though they are not the same. It's the most common way to describe light output from the tip. We tell this that we need a higher intensity light or a lower intensity light. So that is basically what what we are referring to is irradiance of the light, amount of light that is coming out from the tip of the curing unit. This is described in power output per unit area. This is how basically it is described. Unit is milliwatts per centimeter square. Milliwatts per centimeter square. An acceptable minimum range is somewhere around 600 to 1000 microwatts per centimeter square. This is an acceptable one. Up to 400 is still fine. Below 400 milliwatts per centimeter square, your light cure unit is not fit to be used for curing composite restorations. So just have this measured. Now, how to measure it? This is very simple. We may not have it in our clinic, but if most of these representatives who come with, or the company agents who come with a curing light, they normally have this kind of a radiometer with them, or more advanced spectrometry is also available, but that's not really, I mean, it's not easily accessible, but a radiometer is very easily accessible. You can ask one of them to bring the radiometer to your clinic, and then you can measure it just by placing the curing tip on top of the radiometer. Now that will give you a reading. If that reading is around 600, it's a warning sign that tells you that you need to think about buying a newer light. Or if it's below 400, don't think about, just go ahead and buy a new light. Okay, now this is that was about the intensity of light. Now, but diameter of light guide tip again is very important. So normally you have this, you can measure the diameter, or if it's a good company, you can actually have it in the catalog itself. What is the diameter of the light guide tip? Now, this light guide tip somewhere around 7 millimeters or 8 millimeters is supposed to be too. I got muted in between. Fine. Right. So, so the diameter of somewhere around 7 to 8 millimeters is supposed to be too small for restoring a for curing a restoration. So, and something around 10 to 12 millimeters is supposed to be a good diameter. So tomorrow, as you go, just measure the tip diameter. If it's 7 or 8 millimeters, don't bother. We have a solution for it, but it will take more time. Now, most of these things, most of the shortcomings of our existing machine can be compensated if we spend a little more time. And so is the case with your diameter of the light guide tip also. If your diameter is very small, what you can do is you can cure your restoration in 2 steps. You can cure it on one surface, on one area, then you can cure the next area, but only thing is that it should be overlapping with each other. so that you do not miss any area that needs to be cured. So that is one technique. But if you have a larger larger light guide tip, don't bother. You can simply go ahead and cure it in a single position. But we have certain modifications also. We'll discuss. But this is how we normally go ahead with the curing light. See, for example, in this case, the light cure tip is covering the entire tooth, but on the right side you see that only a part of the tooth is covered, or a small part of the tooth is not yet covered. So after curing this surface, you have to move the light so that when it's overlapping with the previously cured surface. So that has to be taken care of. So if you have a small tip, don't worry, you spend extra time for overlapping the restoration. Okay. Now about the beam profile. It's not something that we can measure or we can see in our normal daily practice. We need to have profile meters to measure this. It's not available. So what we can normally do, I'll discuss about it. Then what it means is the uniformity of the irradiance over the surface of the light tip. Now, what it means is this. See, for example, if you consider this light, you can see that the yellow or the slightly orange area is the area through which the light is emitted properly. Okay, that is called as the hot spot. The area around this is the cross section of the light guide tip. This is an ideal situation or an optimum situation where you see that the light is emitted all through the surface or the cross section of the light guide tip. Now this is a less than ideal situation, and this is the situation with most of the light units that we have. That light is only emitted through a small part of the diameter. We've discussed about the large diameter light guide tips, but the whole of that large diameter light guide tip or small diameter light guide tip does not emit the light. Only a small amount of small area of the light guide tip emits light, and that is called as the hot spot. And the other part of the light guide tip, it emits light, but the intensity is not adequate, and that is called as cold spot. Again, if you just look at the tip and observe, you cannot observe with your naked eye what is the profile. You need specific instruments for that. So what can we do to overcome this? This can easily be overcome by not keeping the not keeping the light guide tip over a particular area stationary. All you have to do is keep on moving so that if there are any cold spots, whole of the tooth structure is covered by your hotspot of the curing light tip. So that is one basic thing that you have to do, that while curing, you have to move the curing light. Now, when you move the curing light, the total time that you take to cure increases, because you don't know about the quality of the beam that is coming out. If you have a well-researched instrument with you, probably you can go ahead. If the company claims that they have an optimum beam profile, you can go ahead and keep it stationary. But if you are not sure, because many of us, we still continue to use Chinese instruments or lower quality, or the companies without proper R&D. So in such cases, we have no idea about the profile, beam profile. So in such cases, you just keep on rotating or keep on moving the light guide tip over the restoration, so that somewhere or the other, the hot spot is coming in contact with the restoration and you get some amount of curing there. Now, if suppose the company says you need 20 seconds of curing, but if you keep on rotating, you will have to double the curing time to 40 seconds. So that is again something that you have to spend extra time on, but still you can be assured that your restoration is getting cured, actually cured, and not just hard, which is very important. Now, the quality of beam or beam divergence, this is another variable that we are discussing. If the beam is very much divergent, what happens that there is significant loss of intensity or irradiance with the distance. For example, if suppose this is the beam profile of the quality of the beam of the first light, what happens as the distance increases, the
intensity decreases drastically. But if you have a well collimated beam, like our X-rays, if you have a well collimated beam, there will be minimal loss of radiance with distance. Of course, the intensity will reduce with the distance, but the loss of intensity will be much lesser than the beam with a divergent beam. Now, how to measure or how to observe the quality of your beam? You can you can go to the simple YouTube video here by Dr. Johan Chako about curing light face off. I mean, just write the cola water challenge of curing light in your YouTube, and then you will come to this video. It's a very nice small video which you can try tomorrow at your clinic itself. It's a very simple way of understanding what is the amount of divergence that your beam is creating. Okay. So this is suppose a well collimated beam will be like this, and a divergent beam will be like this. If something is kept at this point here, you can see that this may still continue to cure, but under this light, something at this point will not receive any intensity of light that can cure the composite. So that again is very important. Now about spectral output. Spectral output, what we are discussing here is about the newer advancements, or the what we say as the third or fourth generation light curing units, which the company claims. Generations are not probably not very scientific. It's what the companies claim. Now these so-called newer generation light cure units, they are supposed to be, they are what they call as polywave or multi-wave lights. What this means is they emit light of multiple wavelengths. Now, if you see this one, it's a study again by Price in 2019. He compared 3 different brands of light curing units. I will not go into the study as such, but this is just to understand that the Deep Cure S, which is, I suppose it's by Dunsky, I'm not very sure. So Deep Cure S has a high intensity, or the peak output is at somewhere around 450 nanometers, 450 to 470, which means that this emits blue light. Now another brand, the Blue Face style, that has 2 peaks. The highest peak is at somewhere around 470 only, but you have a smaller peak at around 410 nanometers. Now this is targeted for a certain branch of composite, again by Ivoclar, which they claim to have the newer generation, or the newer classification of photosensitizers, which are called as ivoserine. Now, same with the ultradent Valo, we have another, you have 2 or 3 spikes here. You can see 3 spikes here. One is at around 410, other is just around at 450, 470, and other is at around 490. So you have lights with poly or multi-wave peaks. Okay, now what is the significance of this? See, this is what we discussed initially itself. This is the this is the different what photosensitizers we see in different brands of composite. One, the most common one is camphoroquinone, which absorbs light at the range of around 460 to 470 nanometers. Now, how important is the use of polywave? The studies are still very confusing. There are studies which say that polywave lights need to be used if your composite has these kinds of extra light curing photosensitizers like ivoserine or TPO. But again, as per a study done by Price on a commercial magazine, what he claims is that even your single wave composite curing light is good enough to cure these kinds of newer gen, or the so-called newer generation composites. So the need for a polywave light is still very confusing. But considering again considering the amount of investment extra cost, I still believe that we need to wait for more conclusive evidence before we invest in those kinds of costlier lights. If you have one, well and good, don't bother. But if you don't have, and another thing is that most of the composites, even the newer composites, they do not have any of these TPU or ionoserin kind of photosensitizers. They are still based on camphoroquinone photosensitizers. So all what you can do is avoid composites which claim to have these kinds of extra sensitizers, because your curing light is not capable of curing it. You can still have good quality or best quality composite restorations with other brands of composites. That's what I personally suggest, and that's what I normally follow also. Now about the coming to operator technique. So we have discussed about all the variables related to your light cure units. If any doubts, we can discuss it at the end of our presentation. Now, the second variable here is about operator technique, which can be a very variable. I mean, it can vary a lot, as it can vary a lot from operator to operator. So coming to operator technique, we'll basically think about two things. One is about the position of the light, and other is about modifying your curing techniques. Now, the position of the light, we have two things to consider. One is the distance of the tip from the substrate. Substrate means the composite. And second criteria is the orientation or angulation of the curing light tip. About the distance of the light from the substrate, many times we see curing lights being kept out of the mouth, maybe for curing even the molars also. This has a big problem that your composite may look hard at the end of the restoration, but it will not be properly cured. So what is the ideal distance? It should be as close as possible. As close as possible, it can even be touching the composite restoration. Okay, that is the ideal situation. Now, in this case, you can see I've kept it as close as the restoration as possible, maybe max 1 to 2 millimeters away from the restoration. This is again ideal situation. This is not possible in the posteriors. We'll come to that. Now, what if you keep at this distance? This is a hard, I mean, this is a good, say 15 millimeters probably away from the restoration. At 15 millimeters, you can be assured that your composite is not cured, it's just hard, that's all. And it will fail sooner or later. I mean, it will fail sooner, not later, either by fractured restoration or by secondary, or maybe a secondary caries or discolored restoration. So that is because with increasing distance, the irradiance decreases drastically. Okay. Now that was the ideal situation where our composite, I mean our curing light is kept in contact with the restoration. But ideal conditions, they rarely exist. In such case, in most of the cases, we say that our composite curing light will be at around 0 to 8 millimeters away from the composite. Curing light will be at around 0 to 8 millimeters, because we need to cure composite. I mean, we need to cure composite that are kept in deep cavities also. Such cases, the distance may go up to 6 to 8 millimeters. That is what studies normally suggests. Now, this is again not always possible, because many of the times we need to have a retainer or a matrix system to go ahead with the restoration. This again reduces, or this again increases the distance between the light cure unit and the restoration margin, and the composite at the restoration margin. So again, all these compromises are there if you consider the distance. Now, how to overcome it? If your light has good intensity, this can be overcome by extending the cure time. And that is possible only if you have a light cure unit with really good intensity, say around something around 1000 milliwatts per centimeter square. If we have hardly 400 milliwatts per centimeter square, it's not going to work. And how to measure it? You cannot measure by just seeing. You have to use a radiometer to measure it, as discussed already. So if you have adequate intensity, you can increase the curing time so that the amount of light or the photons that reach the composite is compensated by the increased curing time. Now about the angulation of the tip, the curing unit should be parallel to the surface that is being cured. This is very important. If your curing unit is at angulation to the surface that is being cured, again, this reduces the intensity of the light that is hitting the restoration. So again, very important to keep the curing unit parallel to the surface that is being cured. Now about modifying the curing techniques so that we get a much better serviceable composite. That's also important. How can we modify the curing techniques? These techniques are modified so that we minimize the effects of volumetric shrinkage, along with what we say as polymerization shrinkage. We cannot remove or minimize volumetric shrinkage, but we can definitely reduce the effect of ill effects of volumetric shrinkage on the dentine. Now, these are the most popular ways of avoiding or minimizing the effects of volumetric shrinkage. One is to start with a soft start polymerization. Soft start polymerization, many of our LED units, we have certain modes for soft start polymerization, where the polymerization starts with a smaller intensity, and within a few seconds, maybe 3 or 5 seconds, the intensity reaches maximum. So that is one way of doing soft start polymerization. You have other techniques also. If your light cured unit does not have that mode, what you can do is keep the light at a particular distance away from the restorative surface to start off, and then as you see that the intensity, as you see that the time increases or the time goes on, you can bring the light curing unit closer to the surface. So again, that is a technique of initially starting with a lower intensity, and as with time you can increase the intensity. Now there are other techniques that like pulse delay technique, ramp cure technique, basically all techniques related to soft start polymerization. These are names of the modes that you see on many of the light cure units. Pulse delay is just like spurts of light, a few, hitting for a second, then the switches off, then again for 1 second, that's called pulse delay. Then similarly, you have this ramp cure also, where the intensity increases with time. Okay. So these are the techniques by which you can, one of the techniques by which you can avoid the effect of volumetric shrinkage. So this is the advantage of using a soft start polymerization, that when the light hits on the composite surface, this is the composite surface. When light hits on the composite surface, what happens? There is shrinkage of composite, and the shrinkage is always towards the light source. Now, when there is a when there is a shrinkage towards the light source, if you are starting off with soft start or you are starting off with small intensity, there will be some part of the restoration that is still not cured. So that will flow and compensate for the polymerization shrinkage. And this can help in reducing the stress at the tooth or the resin dentine interface. This is the tooth and composite interface. And this area is what is normally stressed when there is lots of polymerization shrinkage. When there is some amount of compensation from other surfaces, this stress at this margin is very well under control, and you do not have the ill effects of your polymerization shrinkage. Another technique of reducing the polymerization shrinkage or the effect of polymerization shrinkage is to place the curing light on the walls, buccal or lingual walls of the restoration. You can see here that the restoration is kept at the buccal, the curing light is kept at the buccal wall and is cured from one of the walls, buccal or lingual walls. What it essentially does is the shrinkage happens towards the resin dentine interface. There's a composite dentine interface. The shrinkage happens towards the interface so that there is no stress at this interface. This is one technique that you can all employ. But again, the point here is do not count this in your total curing time, which is very important. That the company said 30 seconds, I am doing 30 seconds, but out of that 10 seconds on this and 10 seconds on this and 10 seconds on this. Do not count it that way. 30 seconds if they say, and if you are doing all these things, your curing time will go up to 60 seconds because you are first starting with your buccal and lingual walls, then you are starting with your soft start polymerization, then you go ahead with your complete polymerization. So in such cases, you have to increase the total time that is required for your curing. So, okay, now that was about the operator technique that we need to take care. Now of the restoration characteristics, about the position of the tooth in arch, which is very important because as we discussed earlier, we need to have the light cure units parallel to the surface of the restoration. So if it's very posteriorly placed and your tip design is something like this, and the patient has a very limited mouth opening, it may not be possible to place the restoration, place the light cure unit parallel to the restoration. So in such cases, we'll have to do some other kind of compromises. Some other kind of compensations. Okay, right. So about the location, again, restoration characteristic depends upon the location, size, and depth of the cavity. As the depth increases, we know that the intensity of the light that reaches the depth is also less. So again, you have to consider that for your compensation mechanism. Now, anatomic limitations, we discussed about the restricted mouth opening that can cause certain problems. In such cases, you need either to increase the time of your curing, or if you are planning to buy a newer light cure unit in the recent future, then you can go ahead with buying this kind of pen shaped curing units rather than these kind of gun shaped curing units, because with such kinds of curing units you can place the curing unit anywhere on in the oral cavity without compromising on the angulation. Your curing light can be always be parallel to the restoration that is being done, but this may not be possible in all cases. It's very difficult to do in all cases. So I generally prefer this kind of curing units for my restorative works. And that was about the restoration characteristics. Now about the curing energy requirements. Curing energy is measured or is calculated as a product of irradiance or intensity, what we call, into the time, product of irradiance and the time of exposure. So just to give you a clarity, if by chance the intensity is less, you can compensate that for the by increasing the time. But again, minimum intensity of 400 is a must. Beyond that, it's not possible to increase the time of exposure. So minimum intensity should be there, but in case you have certain difficulties or like certain anatomic limitations, then you can compensate that by increasing the time of exposure. Not very relevant that unit is joules per centimeter square, but it is important to note that different materials have different energy requirements, and that we need to understand. We cannot simply go by a blind rule that this I'll cure for 20 seconds, this I'll cure for 25 seconds. That there is no blind rule like that. What the manufacturer tells is a general guideline based on ideal situations, but ideal situations never exist in patient's mouth. So we have to see what are the conditions or what are the variables of energy requirements. See, for example, certain manufacturers, they suggest or they have composite, they make composites with higher energy requirements, or depends upon the shade of the restoration, very dark or very bright shades. Both these require more energy. The medium ones may not require that much energy, but very dark and very bright shades, they require more energy to cure. Now about the opacity, as we know, as the opacity increases, it does not allow the light to pass through easily. So when it's opaque composite, you have to spend in more time to cure the depth of restoration. Now the filler content. For example, with flowable composites, we know that the filler content is lesser. In such cases, you have to increase the amount of time, or it requires higher energy of curing. Then microfill composite, they need higher energy. We still have microfill composites available apart from the nano hybrids that are more popular nowadays. If you are by any chance you are using microfill composite, make sure that you increase the energy requirement, that you increase the time of curing. And for bulk fill materials, with bulk fill materials, what the manufacturer suggests a depth of cure of around 4 to 5 millimeters. So, but again, if you have to use a bulk fill material, if you want to cure a bulk fill material, ensure that your curing light has a minimum of 1000 milliwatts per centimeter square. Simply do not go ahead with bulk fill material with a normal curing light. Again, you have to ensure that your curing light emits a minimum of 1000 milliwatts per centimeter square. Then only buy a bulk fill material. Otherwise, the depth of bulk fill material will still not cure, which is very important. So on an average, a 2 millimeter thick layer of composite may require around 6 to 24 joules per centimeter square. There is no way we can measure this, but of course we have, based on the guidelines, we increase or decrease the time based upon the type of material that we are using. Now this is a general guideline for curing a 1.5 to 2 millimeter composite. Why 1.5 to 2 millimeter? We'll just see. If you are using a low intensity light that is less than 1000 milliwatts per centimeter square, your average curing time should be around 20 to 40 seconds. Okay, the range is very big. And if you have a high intensity light, which gives an output of around 1000 to 2000 milliwatts, then your curing time should be around 10 to 20 seconds. Now, if you are using a dentine shade or a more opaque shade, the same thing will apply, but we have to use only 1.5 millimeter of composite, or even lesser than that, because it's not possible to measure 1.5 millimeter of composite. So ensure that your restoration or your increment is not more than 1 millimeter. So that is one way of keeping your restoration or your curing on a safer side. If you are using enamel shade, you can go up to 2 millimeters, no problem, because enamel shades are generally more translucent than your dentine shades, which are normally very opaque. So these are the general guidelines. Now, no composite restoration will be complete in this 20 or 40 seconds. One reason is because you are doing it in multiple increments. Even if you are not doing it in multiple increments, this is just for the ideal situation, and ideal situations do not exist. So a low intensity light may be used or may need to be used for at least 2 to 3 minutes for complete curing. And now, how about using the curing light for all these 2 or 3 minutes? Because you are extending the curing time, and all this light has, these are all high intensity lights, and then this will increase the temperature of your restoration or of the pulp. So it can have a hazardous effect on the pulp. So how can you overcome this hazardous effect on the pulp? You have to be very cautious, because you may burn the pulp or cook the pulp, as they say. Okay. Now, these are the basic techniques by which you can prevent the excessive temperature rise. One is to give gap or intermittent stops.
Hello, Dr. Vijit. Hello, doctor, you are not audible.
Am I not audible?
Yeah, now it's fine. Now it's fine. It's working.
Dr. Ashish?
Yes, doctor. Yes, doctor.
Yeah, okay. I just got a feedback. I'm not audible. That's
No. Yeah, you are not audible, but now it's fine.
now it's fine. Okay, great.
Yeah.
Just interfere just if in case there is any trouble. Okay.
Sure, sure.
Right. Thank you. So, what are the techniques to prevent excessive temperature rise? One of the techniques is to give a break in between. See, for example, if you are using a normal intensity light, you can give a break every 10 seconds so that you do not allow for the heat buildup. If you are using a very high intensity light, try to give a break every 3 or 5 seconds, which is very important, so that you prevent heat buildup and prevent the burning of pulp or cooking of pulp, whatever. So that is one technique. Another technique is that you can ask your assistant to blow three-way syringe air through the three-way syringe. Ensure that no water is coming out, but continue to blow air through the three-way syringe so that that dissipates the heat away from the tooth. So these are two techniques. I try to follow the first one because then I am sure that I am stopping the heat for a few seconds at least. I continue to do the curing by giving small breaks of 1 or 2 seconds in between. Okay, so that was about the 4 variables that we need to take care of while doing the curing. Something about curing light maintenance, because this is something again which we overlook very often. What are the things that we can do to maintain your curing light in good condition? One is to clean the tip. Right. One is to clean the tip. Most often we see that your tip of your tip of the curing light may have composite remnants on top of it, or maybe some other kind of dental material remnants on top of it. It's important that you remove that completely, because maintaining those remnants there will drastically bring down the intensity of the light. Again, if you are, you are supposed to use a cling film or you're supposed to use a cling film or some kind of sleeve to prevent the contamination. When you are using that kind of a sleeve, you have to again note that your intensity is coming down. Many of the studies, they say that the intensity is not, the fall in intensity is not very significant, but still there is some amount of drop in intensity, which I have personally checked in my radiometer, which I understood that there will be at least a fall of around 200 milliwatts per centimeter square. Something which emits 1500, after you put the sleeve, will give only 1300. May not be statistically significant, but there is a drop. So in such cases, increase the time of curing. Anyway, you have to keep the tip of your light curing unit clean by wiping it completely. And if you have any break or damage at the light guide tip, it's important that you change the light guide tip immediately, because when there is a damage or a break in the light guide tip, that area is where there will be leakage of light. And if already you have a bare minimum required intensity, if there is leakage, what will happen is the amount of light that reaches the restoration will not be proper. So that again can damage the, that again can affect your curing. Then you have to do a periodic check of intensity or curability. Radiometer, you can, many of the Chinese companies like Woodpecker, they give a radiometer. To what extent that is believable is a different question, but at least you can check the fall in intensity with time. Suppose if I buy a new instrument today and I see that the intensity is around 1700, well and good. But with time, if I check after 6 months, it may be around 1300. It is still usable. But after 2 years, if I see that it is below 400, it shows that it is time to throw the instrument and buy a new one, because repairing is not very easy as far as these kinds of brands are concerned. So in such case, it's important that you check for the intensity. Now, another technique by which you can check the intensity is to do a test cure of composite. Now you can do this. This is a kind of matrix that they give with woodpecker light cure unit. Now these are small bells, and this bell that I'm filling right now is around 4 millimeters. So I fill composite in that 4 millimeter well, and I cure the light from the top. I mean, cure the composite from the top, and then scratch the underneath. And then I can see to what extent this is a 4 millimeter deep cavity. Remember, that's a 4 millimeter deep cavity. So obviously the other side will not be cured properly, but still you can see the change in intensity with the time. Suppose when I bought the new one, it was getting hard, but now after 6 months, if it is not that hard, it shows that there is a significant loss of intensity with time. Okay. So these things that you can do, but even without such kind of things you can do, you can make a ball of composite that is 4 millimeters, or a cylinder of composite that is 4 millimeters, and then cure it from one side and observe the other side by scratching that area. So that can give you an idea about what depth of what depth your composite is getting cured. Now, very important thing is to charge your light cure unit regularly. This is really important, because don't wait for the battery to drain. It's good to charge every 2 or 3 days, because you need the charge at near full, not even 50%. You need the charge at near full. There are studies which confirm that a highly or a fully charged battery can emit the best intensity. As the charge reduces, the intensity of the light also reduces. So in case you feel that your battery is not getting charged fully, or there is some issue with the battery, do not work with a malfunctioning battery. Go ahead and replace the battery. It will be much cheaper than replacing the light cure units. So these were the maintenance tips. Now, very important to break the chain. So we need to have a proper infection control protocol for our light curing units. As I said earlier, use of sleeve or cling film is the best thing to do, so that your instrument, your curing light is always free of cross contamination. You are not cross contaminating when you are using the sleeve. But again, there is a decrease in intensity which you have to keep in mind, that when you use a sleeve, there is a decrease in intensity, though not very much significant. Cold sterilization techniques, by wiping with your wiping with disinfectants also you can do, but I believe keep putting a sleeve is the best way to overcome any kind of to overcome the issue of cross contamination. Coming to the last part of our session today about safety precautions. What is the kind of safety that we need to take care, that we need to adopt while we are using light cure unit? The problem with these lights are that they are very high intensity lights, very high intensity blue lights. And these high intensity blue lights can damage your retina. It can cause irreversible retinal burning. If you stare at these lights for a significant length of time, it is definite to damage your retina irreversibly. It can affect your vision irreversibly, and that is if you see it for a very long time. Even if you don't see it for a long time, chronic low level exposure can accelerate this retinal aging and degeneration of retina, which we are all prone to be, because we are not going to stare at the light for a quite long time. But if we continue to do this small time exposure also, the ill effects are additive. It's not that today you see and tomorrow you see that effects are not related. It's not like that. The effects are always additive, and it will accelerate the degeneration of the retina. And the issue is more pronounced if you have undergone surgery for cataract. So this has to be kept in mind because blue light is quite hazardous to eyes, to such an extent that now companies are coming up with eye safe blue lights or eye safe LED lights, not for your curing units, but for your ambient lighting, which means that LED lights of older generations are generally harmful to the eyes. And with the high intensity light that we use, the damage is even more. Okay, so this is very important. Now, how to protect yourself from curing light, in health hazard of curing light? One very popular technique is to keep the light in patient's mouth and look away. But this is not at all a recommended technique, because by the time you're curing, when you started off the curing with a molar tooth, by the time you end the curing end of 20 seconds, you see that the tip is maybe at the incisors or even near the nose. So this is not the way to protect yourself from the hazards of blue light. This is the way to protect yourself from the hazards of blue light. So you normally get these kinds of orange filters or blue blockers with most of the curing light systems. But many of the companies, they give very small curing light blockers, I mean the blue orange filters, which are inadequate. When you have to look through like you are shooting through that, and then only you will be protected from the blue light. So if at all you come across such a large orange blockers filter, not very costly, it is very cheap considering the advantage that it provides. You and your assistant both are protected from the blue light hazard, and both of you can continue to look into the cavity and do the restorative work, curing work. Okay, this is the best method of protecting your eyes. Now, to summarize the whole session, adequate curing of restoration is essential for its long-term service, which we all agree to that. And even the best of the materials and techniques fail if curing is improper. So this is again very important, that in spite of all the best materials and techniques, if your composites are failing, you should seriously consider about improving your curing techniques. Curing is a multifactorial process that needs optimum integration of a good light, which again is very important, and a proper technique. You cannot have the best light and do not consider the technique. So you have to have adequately good light and really good technique. The combination will work surely. Also, the possible hazards both to the patient and the operator has to be taken care of. So next time you buy a curing light, will be a very good idea to visit the manufacturer's website and learn more about the product and buy, especially because you have most of these big companies, they are coming out with many varieties of curing lights. Now you cannot go for the curing light which your company agent suggests. What you can do is go to their website, learn more about what are the advantages each light provides above the over the other light, and then based on that you can buy, because this polywave and all, they are required only for a small minority of restorations. So is it really worth? If you are really working with that kind of composite, well and good, you can go ahead and buy such curing lights. If not, it's better to avoid that extra investment in your curing light. So these are the references. If anybody of you want the references, just let me know. I can send it through this reference. And all these are simple and very clinically relevant articles. And thank you very much. For any kind of doubts, you can contact me. And this is my Instagram page. You can see some amount of dentistry and large amount of photography in my Instagram page. Thank you.
Excuse me, sir.
Yep.
Am I audible?
Now, yes.
Sir, can I ask my doubt?
Yeah, sure. Or is there someone who is coordinating with the doubts?
Okay, sir.
No, Dr. Vijay. The
Yeah.
person can directly ask you that. doubt.
Okay, right. Because I see a couple of questions in chat box. No problem, doctor. Go ahead.
Sir, I'm using blue phase NM from Ivoclar, and it is with cord. So should I upgrade to cordless? And the intensity is less than it's around 900, 800 to 900 range.
I mean, there's no point in upgrading just because it's with cord. If it is giving adequate intensity, you can go ahead and work with it. No problem. See, 800 to 900 is good enough, and especially if you are having that with a good branded one, the chances are that you have a really good beam profile, and most often the beam will also be well collimated. So in such cases, 800 to 900 should be good enough. I mean, no need to upgrade to a cordless one.
Okay, sir. And
And
one
yeah.
more thing, sir. Kindly explain this soft start, sir. Should I use actually at base I use flowable material. Then I put restorative.
Okay.
So, sir, we should go on increment wise, like so.
Yeah.
It
I
takes
mean,
longer time. So it takes longer time for curing.
yeah, it will take normally, because as such your flowable composites need a much longer curing time than packable composites, and especially if you are using that at the base of the restoration, again the distance from the light is also increasing, so it definitely will take a longer time, no doubt about it. But the advantage here is that even if you take a longer time, the amount of time you spend, you are getting in rewards for the life of the restoration. So
So,
if you
so
are
this is
using
the
flowable at the
right
base,
technique. So
yeah,
you say
that
this
is
is the
really
right.
absolutely right technique. And then when you are doing it in increments, you don't have to worry about heat buildup also. Now
Okay,
about
sir.
the kind of increment, that is an entirely different topic. How which way to do the increment best,
Oh,
which
yes, sir.
means
Yes, sir.
difficult
That
to
is
explain
discussed.
now. Yeah, but then if you are doing in increments and your light is somewhere around the 900, 800, 900, you can definitely go ahead. And then one advantage with corded ones is that you don't have to bother about charging. You will always
Yes,
get
sir.
the best intensity, because
Yes,
if
sir.
it's a battery operated one, the intensity will go down if your charge goes down. So
Yes,
don't
sir.
bother about upgrading, no issues.
And sir, in injection molding technique, basically, when we heat the composite, sir, when then we put all the compule, that whole compule
Yes,
at
yes,
the
yes,
time. So
yes.
in that time, sir, what should be the timings for curing?
See, for injection molding, it's not always in a single go. You have to see for the depth of the restoration, because if the depth is more than 5, again your bulk fill composite also will, you may need to do it in two increments. The bulk fill also has a maximum limit of around 5 millimeters. So
Yes.
if your cavity is 8 millimeters deep, maybe if you are doing a core build-up or something like that, you cannot do the whole restoration in a single go. You may have to do it in two different goes. And if you are using a bulk fill, you have to have a light cure unit that is more than 1000 milliwatts per centimeter square. That is a must. So
Okay.
if you are using bulk fill technique, then better to go either to upgrade or then avoid bulk fills and go ahead with your normal layering techniques only.
Okay, sir. Actually, with BioClear matrices, I do that. So
Yeah.
should I stop
No,
now?
again, I mean, see, again, it's like you can incorporate other ideas also, like curing from the buccal and lingual surface.
Yes, sir. That's what I do.
That you can do. I mean, then you have, again, you have to increase the time, but not all the 8 millimeters together, or not all the 8 and 10 millimeters together. Even if you are using BioClear or injection molding, But
Yes, sir.
even BioClear, they suggest to do it in 2 sessions. I mean, 2 increments. If the depth is more than 5 millimeters. In
Okay.
fact, you can use a perio probe. That is what I normally do. They have a depth gauge by BioClear, but don't go for such
Yes.
things. You can have
Yes, sir.
a perio probe to see the depth and then decide on how many increments you need to go for.
Okay. Sure, sir. Thank you. Thank you so much, sir.
Welcome.
Dr. Vijay, Dr.
Yes,
Ashok
yes.
Galav has a doubt regarding for ortho bracket, any suggestion for curing? He's asking.
Yeah, ortho brackets basically, see, you the idea is to illuminate the area of cure, I mean your resin cement. So if you cure from the top, you are not actually reaching the resin cement. So you have to cure from the sides. That is the only suggestion that I can give, because I don't do orthodontics. One suggestion that I can give is cure from all sides. That is the advice given to me by my orthodontist, that cure from all sides, because I don't do ortho, I have no much idea. But you should not do from the top. You should not do just from the facial, because the light is not going to reach your curing light, I mean your resin cement. Is that okay?
I hope so, Doctor. And Dr. Arpita and Dr. Manoj Thomas want to
How to
know
clean
the
the
method
curing
of
light tips?
cleaning curing light. Yeah.
I mean, see, basically, any disinfectant agent should work. Even a spirit or alcohol swab should be good enough to clean. But to what extent that the disinfects the tip is another story. So I normally prefer using a sleeve, which I feel is a more foolproof technique. And then after you remove the sleeve, you can wipe it with the alcohol swab, no problem. And if there are composite that is attached to the tip, it's very difficult to remove. You have to remove it with a sharp instrument that can cause scratch on the tip, and again that will reduce the life of your light guide tip. So my best advice will be to use a sleeve always.
And
What-
now Dr.
What-
Ranjit George,
Yeah.
what about 1 second curing light?
No, see, basically what happens is in 1 second curing lights, I mean, 1 second means the intensity will be more than 2000 milliwatts per centimeter square, which is too big an intensity. And what happens with such intensities is that your polymerization shrinkage happens in a single second. Just imagine the amount of stress that resin dentine interface will have. So avoid 1 second curing lights. They are, 1 second curing modes. It's good that such companies, they have such high intensities, but never use those intensities for your practical purpose. You can always start with a soft start polymerization. That is the best way to start. And then maybe as with the time, you can increase the intensity. Somewhere around 1500 is good enough. More than 2000, it increases the stress very drastically, and it can be very severe also. And moreover, the heat also. Heat it generates or it imparts to the pulp is also very high. Try to avoid. That's what my personal suggestion is.
And next is Dr. Smita K. Jose. She have two doubts: whether availability of the radiometer and how to check the hotspot in curing light.
Yeah, so radiometer, you will easily get it from your any of these light cure agents. For example, if maybe you can ask your Cavo or 3M representative, they normally have this radiometer with them. Then many like woodpecker companies like Woodpecker, they give one free with the kit. I don't know about the reliability. I have personally checked the reliability. It's quite reliable. Maybe there is a difference of around 100, a reading of around 100 between the Cavo and the Woodpecker one. But still, I believe that's okay. You can at least see the difference or see the change with the time. So getting a radiometer is not very difficult. The next was about beam profile, right? About hotspot.
Yes.
Yeah, that is very difficult for us. That's not very practical for us to see the beam profile. Maybe you can go to the company website. these companies, they normally have beam profile of their light cure units, and everybody will say that theirs is the best. That's a different thing, but that is the only way we can reliably see about the beam profile, or otherwise you need to have profilometers. I don't know about the availability of profilometers. I don't think it's very easily available. Maybe with the research centers and all, they may have profilometers. I have no idea about that. But clinically, it's not possible to see or feel or differentiate between hot and cold spot, because you'll see light from all these areas. Only thing is, hot spot has adequate intensity, cold spot does not have adequate intensity. It's not possible clinically to differentiate.
The next doubt is by Ranjit Raj.
Yeah.
Do we need to use orange filters while using light present on the loop?
Yes. The reason for using a filter when using a loop or microscope is because your composite can get cured prematurely. While you are doing the carving itself, the composite can get cured. So that is the reason why we are putting an orange filter. That orange filter is to prevent the light from falling onto the composite. Now, the orange filter that we use otherwise is for preventing the light from reflecting onto our eyes. So actually that is used when you are only when you are light curing. The other filter that you are using that is present on the loop is when you are working with the composite. Hope I am not confusing. So both are required. When you are using a loop, you have to have orange filter on the light so that your composite does not get cured prematurely. And second, you have to use the larger orange filter that I showed in the presentation so that you do not damage your eyes. Even through the microscope or even through loop, the light can reach your eyes and it can damage.
Now, Dr. Senni has a doubt regarding, can overcuring create any problem other than pulpal overheating?
No. Basically, composites, there is no issue with overcuring. You cannot overcure your composite. So extending the curing time with adequate gap in between, it actually is a technique. See, there is nothing like you cannot overcure or over strengthen your composite, but you can definitely prevent undercuring. So there is no other harm if you take care of the pulpal temperature, no other harm.
Now, Dr. Deepthi Santosh, she is having doubt that resin cure cements for crown and post-anchor, while curing that, whether any precautions to be taken.
For crowns, do we take? Yeah. See, basically, resin, the cements that we use for crowns or post and core, for example, where we cannot, where our light cannot reach, we have to go for dual cure cements. Where there is some amount of light curing that we can initiate, but rest of the curing will happen by self cure. So for such cases, if you are cementing a crown or you are bonding a post or something like that, always go for dual cure cement. Same maybe with your, even with the thick onlays and overlays also, you have to go ahead with dual cure cements.
And Dr. Ashok Galav is now again asking whether 1 second curing can be used in ortho brackets.
Ortho brackets also, you have a vital pulp below it. So I will not suggest. Personally, I have no idea about bonding the ortho brackets. But anything that is close to the tooth and is giving high amount of heat in a single stretch, I will not recommend. That is my answer.
Again, Dr. Arpita is asking, sir, can you repeat the values with units for curing light's intensity and energy?
Values with intensity, with units. The unit is milliwatts per centimeter square. The values vary depending upon the depending upon the quality of your light. Generally, something below 600 milliwatts per centimeter square is not acceptable clinically. I have a personal suggestion to keep your intensity around 800 to 1000 minimum. And if you are going with the bulk fill composites, if you want to use bulk fill composite, which again will help reduce a lot of your clinical time, you should have a curing light with a minimum of around 1000 to 1200 milliwatts per centimeter square. Something beyond 2000 milliwatts per centimeter square, you have to be very, very careful when using such systems. Unless you are using root canal treated, using it on a root canal treated tooth. Even in that case also, the polymerization shrinkage, the change in volume will be very fast. The change in volume will not be more, but it will be very fast for compensatory mechanisms to work. Hope I am clear. If I'm not clear, you can just ask me. You can unmute and ask. I can explain. No problem.
Now, Dr. Gina Koshi wants you to recommend a good curing unit with adequate tip size and power output.
And that is a really tough question to answer. I mean, if it all depends upon your what to say, your financial output, how much you can shed on it. Anything you ask me, is a woodpecker one good? I'll say it's good. If you just that, you have to look at the intensity. Something around 7,000 or 8,000 rupees woodpecker curing light will also work. Only thing is that you do not have a R&D to back up it. So something around 35,000 deep blue, that also will work, no problem. Only thing is, what I can suggest you is, do not shed on polywave systems as of now, because it is yet to change. So do not invest too much amount on curing lights, because there may be a chance that you get a totally new photosensitizer which has a lot of advantages. Maybe that time you can invest on a huge, I mean, you can invest more amount, but as such, invest something around maximum 35 to 40,000 on a curing light. Yeah, I mean, that's all what I can suggest you, because I don't want to specifically name any companies or anything. That's why I'm keeping it to such kind of only for suggestions. Blue Wave is also a good one, but they have lots of brands and lots of varieties. Maybe you can ask. I can let you know after doing a little research on the brands. Because basically, I'm not very interested in such things. I can let you know if I'll just have a personal research and let you know.
Now, Dr. Ashok Alavi is again asking whether the curing lights can be used in bleaching.
Normally, curing lights are not required for bleaching, because most of the curing light, I mean, bleaching agents that you get nowadays, they are chemically cured. Lights have no role in bleaching agents now. So still many people I see, they are using curing light. And then again, curing light, the only thing that a curing light can do there is to impart heat. There is no light curing or there is no light activated bleaching agent available. All that a light cure can do is to impart heat. And none of the major brands available nowadays, they are heat activated. So don't bother. Most of them are chemically activated. The moment you see that your bleaching agent has two components that has to be mixed before applying, it means that it is a chemically activated one. Don't bother about curing don't bother about using any curing units. It's a waste of time and your energy also.
And Dr. Lijo Thomas want to know the average age of light source, just in years, or just the intensity is the.
That's actually a very good question. It's like telling that I'll just give a simple sentence for that. It's like telling I've been using my light cure for 10 years, I think it's 7 years, which means that definitely all these things have a particular lifespan. So I believe, I mean, in changing the light cure source every 2, 3 or 4 years, or maybe max 5 years. If your light cure unit is so expensive, change it after 5 years. That's what I say. Because see, you have to use this for an extended time. Every time you are using it. It's not that you are just showing the light and taking it out. You are using it, and many times you have to overuse it to ensure proper curing. In such cases, I believe you have to change it periodically. How periodically? I do not buy very costly ones, so I change every 3 years. I don't get that pinch because I am not investing on very heavy machines. But if you are investing on a very heavy machine, probably you can change it. But of course, intensity is the criteria to change. There is no other criteria. Fully charged light cure unit, if it gives adequate intensity, you can still go ahead. But with proper use, the intensity will come down with time. There is no doubt about it. Yep.
I think the comment section is closed now. Nobody is responding.
Right.
Shall we move on, or any other doubts?
You can always contact me for any doubts, no problem. I'm always available on WhatsApp. So that's a different thing. So I think we can wind it up, right, Dr.
Yeah,
Ashish?
I think so. I think so. Anyway, thank you, Dr. Vijit, for the very wonderful eye-opening session. Now I call upon Dr. Vishy, Secretary, IDS Center, Kerala, Kottayam, for a vote of thanks.
Thank you, Dr. Ashish. Am I audible?
Yes, Doctor.
Very much, very much.
Very crisp, information-packed, and a very short, very much information-packed class was today's. That is how I want to say about today's class. And we witnessed a very great class, especially from very much on practical aspect, especially, which we all could implement by modifying our techniques in the composite fillings. Especially, this was the first CD of our term. I'm really glad and proud that we started off very beautifully, and I'm sure that everyone would agree to this. With this preface, let me do the duty which is bestowed upon me. First of all, I thank God Almighty for giving us all an opportunity to learn and update our knowledge. Next, I would like to thank the star of the day, Dr. Vijit Narayan, for his excellent class. The session was really enlightening and informative. I really believe all of us got benefited from this very much and have much in reserve to take to our clinics. Looking forward for more sessions from you in the future, maybe offline also. And even the question answer session was also very beautifully handled, and it was really information packed, and that was like an add-on package. Thank you so much, Dr. Vijit Narayan. Sincere gratitude to Dr. Nishant Krishna, the very vibrant state CD chairman, for taking out his time for being with us and for inaugurating our CD session. Thank you so much, Dr. Nishant Krishna. Next, I would like to thank Dr. Manoj Thomas, our president, our leader, our guide in all our activities. Thank you so much, sir, for all your support and the guidance. Next, I would like to mention about our CD chairman, Dr. Ashish Sirek. This year, we are really blessed to have such a passionate, enthusiastic CD chairman on our side. This CD, from its very beginning of planning, Dr. Ashish had been exhibiting his management skills in organizing this very much, and we were really relaxed indeed. I thank Dr. Ashish Sirek for all his efforts and wish you all the success and all good wishes for your future efforts. And also, I thank you for the doing the moderator role in a very beautiful way. Thank you so much, Dr. Ashish. Next, I would like to especially mention Dr. Robin Terwil. I really believe that he has guided Dr. Ashish very much, and I thank Dr. Robin Terwil for his excellent role in this CD. Many of our executive members are participating in the CD. I thank you all for your support and your participation. And indeed, every program is blessed by its participation. I thank all the participants for your enthusiasm in the learning and for your participation, especially from our branch. And there were participants from other branches also, especially even from out of country also, from UAE even. I thank all the participants for being with us and for acquiring all this knowledge. Last but not the least, I also acknowledge the presence of many academicians and many senior dentists are also there in this class. I also acknowledge their presence. Lastly, once again, wishing you all a happy practice, a healthy practice, and wishing you all a very good night. Thank you so much.
Dr. Vijay, Dr.
Yes.
Annie Susan has one doubt regarding the post and core. Curing the post and core, is it same like the crown and?
Yeah, it's basically that you have to rely on dual cure cement if you are going ahead with bonding of post and core. I mean, bonding of post, because however good your post system, of course, it depends upon the quality of the post also. It should be a good quality post which can transmit light. That's a different story. But in spite of the best quality post, transmitting adequate intensity to that depth, maybe around 12 or 14 millimeters into the canal, is very difficult. So I still believe strongly on using dual cure resin, dual cure cements for core buildup, for post and core.
Even for crown cementation, right?
And crown cementation. Crown cementation, absolutely, because especially if you are using a metal ceramic crown, there is no question of light reaching anywhere. So dual cure is the best option. Even with zirconia crowns also, dual cure is the best option. Only for veneers, you can be assured that your light is reaching the resin cement. So only for veneers, we use light cure cements. But all other cases, we use dual cure cements, so that you are assured of the curing that is happening inside.
Okay, doctor. So that's all, I guess.
Yes, okay. Very nice time. Thank you.
Thank you, Dr. Vijay. Thank you so much.
Thank you.
Thank you so much, doctor.
Thank you, doctor. See you all. Good night.
Good night. Good night. Thank you.